Hi, in today's video we are going to cover interpolation and animation of basic canvas elements. We will see how interpolation is used to perform an animation. Also, we will see a method that is used for an animation, that is requestAnimationFrame. So let us start with linear interpolation. What do we mean by a linear interpolation in mathematics? If there is a two-dimensional graph where we have x-axis, which is our horizontal axis, and y-axis, which is simply a vertical axis. If we define one point two-dimensional graphical plane, it is defined by its two coordinate. For example, this first point is given by its x and y coordinate, x and y0 respectively. Second point is also denoted by its 2 points, that is x and y coordinates respectively, which are x1 and y1. If we know any 2 points in a plane which are defined by two coordinates x0, y0 and x1 and y1, we can find a linear path which is simply a straight line between these 2 points. Now, for a value of x in this interval x0 to x1, if any x I will take, I will be able to find out its y value. What actually I am trying to say over here is, if I know any 2 points, I can obviously draw a straight line in that. Now, for example, over this straight line, if I select some point and whose x value I know, I can find its y value using interpolation. Or if I take any y value, say for example that y value is projected at this point, this one, then I can find its x value. So any of these values are known, you can find the other value using linear interpolation formula. Now linear interpolation formula, it goes like this: y minus y0 divided by x minus x0 is equal to y1 minus y0 divided by x1 minus x0, where x0 and y0 are nothing but the coordinates of first point, x1 and y1 are the coordinates of second point, and x and y are nothing but the coordinate of new unknown point whose either x value or y value is known, and we are wishing to find the other value. So I can rewrite this formula in this way, where I am wishing to find out y value or y coordinate for any x coordinate that I know which falls over this straight line. So formula is y is equal to y0 plus y1 minus y0 into x minus x0 divided by x1 minus x0. So this complete formula will help us to interpolate values. Now we will start with this formula. In this formula, these component x minus x0 divided by x1 minus x0 always results between 0 to 1. And we call this factor as our weighting factor. We will always substitute some value between 0 to 1 as in our weighting factor. So the result of complete equation depends on only two y values, that is y0 and y1. Your complete formula can be rewritten as y is equal to y0 plus y1 minus y0 into x minus x0, x1 minus x0. Now this interpolation is not used as it is in our animation. We use the same interpolation formula to perform, not to find out the straight line or not to find out the coordinate, but we will use this formula to perform an animation or for something called as blending. Let us see how. So, first of all, we have seen that our multiplier component or weighting component always ranges between 0 to 1. So, we have substituted our y value that we wish to find as n. Y0 is nothing but starting point of the animation. End is nothing but a point from up to where we want to animate a particular object. So, and speed is nothing but your waiting component. So, formula is rewritten as n is equal to start plus end minus start into some speed. Here, this n is nothing but y, start is y0, end is y1, and speed is x minus x0 divided by x1 minus x0. Speed is nothing but step value or the step size or a blend size or a time value with which you want to move an animation. So you can have fast animation, medium animation or slow animation, which depends directly on the value that you specify on this speed factor. Start value is the value from where you would like to start animation. The place, the coordinate, the actual area from where animation will start. And end is the place where you want your object to be finally at that place at the end of animation. So basically, when we are performing animation, we are moving an object in our canvas from one location to another location. So we must know starting and ending position of that object. Say for example, in this canvas, this red square is the object I would like to animate, and I want to move this object across this horizontal line and move this object towards the right hand side of canvas. So when I will open my page, this square will be over the left top corner, and after performing an animation it will be moved towards the right top corner. That is the only animation that I would like to perform with my object. So for sure I must know what are the starting and ending position of my rectangle. In addition to that, I must know what are the dimension of my rectangle. So this is a square where I will put width is equal to height, and using fill rect method I am going to draw this rectangle. Now one thing you should note that what will happen, we will draw a rectangle, a filled rectangle with some x and y coordinate. Obviously to draw a filled rect we would require 4 parameters. Its starting and xy position. We would require 4 parameters. Its starting xy position, that means this coordinate, as well as we would like to have its width and height. So x and y coordinate and width and height, using 4 parameters, I am going to first draw a rectangle, a filled rectangle. After some moment of time, I will erase this complete drawing and shift or draw a new rectangle at new position, which is slightly towards the right. Again, I will draw a rectangle with new xy coordinate. Just note this difference. Your x and y coordinates are going to change. Again, I will erase this rectangle. Again, I will draw new fill rect method with same width and height rectangle but new x and y coordinate. So one thing you should note that we are keep on repeating two steps. Step number 1 is clearing a canvas. Step number 2, draw a particular rectangle or any object that you wish to draw. So clear, draw, and this keeps on repeating for some time or for some condition or for some event. Now clearing and repeating same step, we are going to write these lines in a one function. Now what will happen to your x and y coordinate? Just note this, your x and y coordinates are changing. But if I say specifically, your y coordinate doesn't change, as you can see, isn't it? Your rectangle is moving horizontally from left to right, then your y coordinate doesn't change. It is always at the same height from your top edge. So the only thing that changes is your x coordinate. So what we are basically going to do in this animation is that We will find out this point as our start point. We will find out our end point. That means after animation, this is the final position I would like to have my square to be. So this x is my starting x and this x is my ending x. I want to change my x value in between n numbers of time. That means first time my square will be at this place, after erasing it will be at this place, after erasing it will be at this place, and keep repeating same. Finally my square will be at this place. So my x is going to change every time. That is the first thing I must say that. So I want to find out my x value every time when I draw this rectangle. Now this x value can be found out if I know y value at that location. So over the same horizontal line, wherever I draw this rectangle, my y is not going to change. So that is the thing I must note. And also I know what is my starting x and what will be my ending x. So start x and ending x must be known. So if start is known, I will use interpolation formula, that is start plus ending minus start into some weight, or I would call it as speed or something else, or say size or step, whatever you would use. That is nothing but your weighting factor and it is deciding the speed of your animation. So to find out new x, I will use this formula. So let us see and understand the code and observe the output for an animating a rectangle. Let me take you to the code window. So this is my code window and this is the code to move your rectangle from one position to another position using an animation. So the heading is animating square. We have one canvas whose ID and some border, width, height, everything is set. Inside script tag, I have canvas and context variable defined just like we have done in our previous practicals. Now have a close look at the declaration of variable. We have one variable start x which is giving the starting x coordinate of a rectangle, that is 10. We have start y which is the starting y coordinate of rectangle. Width and height of rectangle are same, that is set to 50. Now ending is given as, or last point of rectangle up to where your rectangle must go is canvas width minus width, because if you give end x as some value, it might happen that pixel go out of your canvas. So you are making sure that whatever the width of canvas is minus the width of rectangle, that should be the last point. If I would like to say same thing in your representational format, I am talking about end x as this particular point. This particular point. So this point is canvas dot width and this 50 is nothing but width of rectangle. So whatever the coordinate canvas dot width has minus width will give you this particular point. Okay, so that point is your end x, the last x coordinate of rectangle up to where you would like your rectangle to be transited. Now coming back to code, we have x and y coordinate. So every time your x and y coordinates are changing, but we are starting x and y coordinate which are initialized to start x and start y value. Now step size is initially 0. We are going to move this step from 0 towards the right up to 1. And we will take little step to have slow animation, and we will take larger steps to have big animation or fast animation. So linear interpolation is written inside lerp function. So the notation goes like this: to declare a function we must use keyword function. The name of function is lerp, that stands for linear interpolation. If you wish to write complete name, that you can do always. It will take three parameters. First one is start, second parameter is end, and third parameter is speed or step. You can have name of variable as you like. Linear interpolation basically calculates formula goes like this: start plus end minus start into speed or step, whatever the name of variable over there is. So that value is calculated and returned by this LERP function. Now how actual logic is there? The logic is there that every time you increase your step. So initially your step is 0 and at the end of animation your step should be 1. So you increase your 0 value with little amount. So that little step we have chosen it to be 0.02. You can make it as 0.1. So value from 0 to 1 will go in only 10 steps. If you are taking very little value, your animation will be slow. If you are taking larger value, it will be fast. So here 0.02, that means I am interested first in seeing slow animation. Now we are calculating new x value depending upon this updated step value. See here, step is equal to step plus 0.02 is the line. Okay, so step is updated. So according to this step, if start and end are fixed, I can obviously calculate new x value. So if my new calculated x is less than end x, okay, I can obviously write less than or equal to, or I can simply write less than x. That means I have to move my x only up to location end x, not more than that. So whenever this condition is true, we are calling requestAnimationFrame method to draw. Now what is this requestAnimationFrame? RequestAnimationFrame method tells browser that you wish to animate something on your window or precisely in your canvas. Now to animate something, you must draw something, and those drawing steps are enclosed in our draw function. So here the name of function that I would like to call for drawing is the draw function. And where is your draw function? In very next line we have draw function. Draw function does only two things. It erases out the complete canvas and draw a rectangle. So erasing a complete canvas is done by ctx.clearRect method. Now starting point or x and y coordinate from where the canvas should be cleared is 0, 0, and the complete canvas must get cleared. That's why we are writing canvas.width as the complete width of clear rect, and canvas.height is the complete height of clear rect. So this is going to clear your complete canvas. I will put it inside comment clear complete canvas. Okay, now your settings fill style as red. You can choose color of your choice. And next line we are drawing one filled rectangle with x and y coordinate. So note that this x and y coordinates are updated regularly by logic function using lerp function. So here we are making a call to lerp. So x and y are not updated in draw function. We are just supplying value that x is this, y is this, width is this, and height is this. You just draw this rectangle. Okay, so this draw is called by requestAnimationFrame. So from where execution will start? We have lerp function, we have logic function, we have draw function. Neither of this function is going to get called unless and until you start calling at least one function. So to start our animation, we again write requestAnimationFrame and we start drawing with the help of draw function. So from here, your first line will execute it and draw function will be executed for the very first time. Now, after animation draw function is called, we must update x and y periodically. So this logic function should get called to change this x value periodically. To call a particular function Periodically, we have method setInterval. SetInterval will take the name of function that you wish to call and by how much frequency you would like to call. So name of function that I would like to call is the logic function that I have created. Now this function updates x, that means I am wishing to change x by how much frequency. So I must change value of x in 1 second 60 times. So this 1000 stands for 1 second. In 1 second I am wishing to change or call this function 60 times. That's why I can write 1000 divided by 60, or I can simply put this value as 16, which is numerical or calculated equivalent of. It is actually 16.667, but I can obviously round it to 60. I can change this value to 1000 divided by 60 also. So let me save this work and show you what is the effect. So this is the refresh. I'll refresh again. It starts from one place and moves to another place. And the animation is very fast. I want to slow it down. So instead of calling it 60 times in a second, let me make it 30 times in a second. So speed should be divided by half. As you can see, speed is decreased now. I want to more slower it down, 10 times, for example, in a second. Here, in a second, it is calling logic function only 10 times. So your animation is getting slow. Okay, let us experiment something else. I'll keep calling logic function 60 times in a second, but let me change my step size and observe the difference. And let us see the difference. As you can see, it's too fast. And if I change this value to 0.01, for example, it has to be slow and smooth. Let me reduce by one more decimal point and see the difference. It's much slower now. Now the time required to move object from start position to end position is increased if I have small value in this. So speed is actually your step. Okay, so if you have the smaller value, the time required to move an object will be long. The larger value or larger steps you will take, you will move your object very faster or in less time. Two methods now I will be discussed is the first one, request animation frame. Request animation frame is a method which tells your browser that you are wishing to perform an animation and request your browser to call a specific method. In our case, the method was the draw method, and it updates your method or calls your method to update your scene. It takes the name of function that you would like to call, and the name of function that you would like to call is supplied as an argument is called as callback. So the method which takes a callback is an argument of a name of a function that you wish to call. And the second method that we are going to discuss is setInterval. SetInterval method is used to call a specific function or a method in some millisecond or after some period of time consequently. So here set interval method having the name of function that you wish to call, in how much millisecond or how much frequency you would like to call this function again and again is given by set interval method. So we have used 1000 divided by 60, which is calling our function 60 times in 1 second. 1000 is nothing but 1 second represented in millisecond. And function to update x and y, which is nothing but starting point of rectangle, which is written inside logic function. So the name of function is logic. That's why we have used set interval logic comma 1000 divided by 60. In our next video, we will see how to animate a circle or how to draw a circle in an animated way. So thank you everyone for watching this video. This is Munira Topia signing out.